These are pebbles. This is sand. This is my jiggly thing. If by accident I mix the pebbles with the sand, and then thought, oh gosh, I didn't mean to do that, I want the pebbles back, I can use my filter to do that. If I pour the mixture of the sand and pebbles into the sieve, I can put there are my pebbles. I can put that in there, and there's the sand in the bucket. Only that one got through because it was so small it fit through the hole there, but most of it separated. That's because the sand and the pebbles stayed as sand and pebbles. There was no chemical reaction to make them mix. We're doing the same thing again, but this time everything's a bit smaller. This is sugar and this is rice, and here is the sieve. And if I mix the rice and the sugar, we get a mixture of rice and sugar. There's no chemical reaction, it's just rice mixed with sugar. But I shouldn't have done that because I'm going to get a row from Auntie Jean. So I want to separate it. So this time I'm going to use a sieve. Look at the size of the holes, smaller than the last one. There's my mixture. I'm going to pour the mixture into the sieve and jiggle it around. Jiggle it around a bit more. And what's happened is the sugar, because they're smaller bits, have gone through the sieve, and the rice, which are the bigger bits, have stayed in the sieve. So I've separated them, and that's sort of like filtering, which we're going to come to next. This is special paper called filter paper. It's got really, really tiny small holes in it, much smaller than in the sieve. And just to keep it in shape, I'm going to pop it into this funnel, which is going to hold it in shape like that. Now I'm going to make Auntie Jean really cross because I'm going to put some water in this bowl. That's water, and I'm going to pour some rice into that. And what we've got is a mixture of water and rice. But that's no good really, isn't it? Because we don't want a mixture of water and rice, we want to separate them. But the water is made up of really small particles. The particles of the water would go through there, and maybe the particles of the rice might too. So let's use the filter paper. The holes in the filter paper are so small that they'll only allow the water particles through. So put the, can I have an assistance please? Hold that. Right, just hold that there please, Auntie Jean. So now I'm going to pour this into the filter paper. Oops. And Auntie Jean didn't hold it steady. Can we start that one again?
Let's start that again.
No,
certainly.
Pour that liquid back into there, Auntie Jean.
Do you want another filter paper?
No, filter paper's fine, but we need to keep it open, okay?
Yes.
So now we're going to pour that into there, and very slowly, if we lift it up a little bit, we'll see that the water is going through, but importantly, the rice isn't going through. So we're filtering the rice out of the water. So the water goes through the tiny holes in the filter paper and the rice, because they're bigger particles, don't. Now we're going to make a different mixture. This is water. Water is a liquid, and water lets things dissolve inside it. In English, we call that a solvent, the liquid that lets things dissolve in it. And we're going to pour into that some sugar. Not a lot, but there's the sugar. And we know that sugar will dissolve in water. So you can see the sugar in the bottom now, and I'm going to give it a bit of a stir to help it dissolve. Well, the sugar's going to still be there, but it's sort of disappeared. The very small particles of the sugar is hiding, or are hiding, between the particles of the water, and we can't see it anymore. It's still there. If we tasted it, which we shouldn't do in the lab, it would be sweet because the sugar is in the water. It is dissolved in the water. The thing that does the dissolving, the liquid, is called the solvent, and the thing that dissolves, like the sugar in this case, is called the solute. If we filtered that, it'd be no good, because the particles are so small that both the sugar and the water would pass through the filter paper. So if we get rid of the water, we can be left with the sugar. So we get a saucepan, or in the lab you'd probably use a dish. We pour the water in there, we make it boil so the water evaporates, turns into a gas and goes up into the air, and that should leave the sugar behind. You can see the water vapour coming off, and let's leave it a little while and see what happens. After a little while, you can see that most of the water has evaporated, it's gone, and you can just about see some crusty sugar left at the edge of the liquid. Can you see that? And that's the sugar that has stayed behind when the water has evaporated. So that's another way of splitting a mixture, a solution in this case, a liquid and a solid that dissolves in the liquid. And if we leave that long enough, you can just about see here some of the sugar being left in the bottom of the saucepan. It's not a great colour for seeing the sugar that's being left behind, but believe me, it is there. Remember the water evaporating out of the saucepan? That meant the water boiling and turning it into a gas, and the gas then just disappeared into the air. There is some kinds of apparatus, there are some kinds of apparatus that can catch the steam and cool it back down and turn it into a liquid, and that's called distillation. So you separate the solid, which will be left in the pan, the liquid, which turns into a gas and comes away, and then turning the liquid gas back into a liquid is called distillation. And there's a special condenser that does that. The diagram's in your book.